Okay, so once we've got our average titer, sodium hydrogen carbonate, we pipetted, we'd already previously made it, so we pipetted that out and put it into our conical flask, so that was a fixed volume. From making up as a standard solution, we would have calculated the concentration. Now in my case, I measured out 2 grams of sodium hydrogen carbonate, and that gave me a concentration of 0.0952, which I'm going to put in here. So it's something that I've calculated previously. So I know this concentration. So 0.0952 moles per decimetre cubed. Because this was what I was pipetting out, this is my fixed volume of 25 centimetres cubed. So I can put that in my table. So I've set this table up to work out concentration, moles and volume. So the volume was 25 centimetres cubed, which I'm going to convert into decimetres cubed. And to do that, I divide it by 1,000. So divided by 1,000, the volume in decimetres cubed is 0.025. I'm going to use that later. So given that I know the concentration and the volume, I can work out the number of moles. So I've got 2 out of the 3 and I can work out the number of moles, which I can do quite easily using the equation cats never vote, so CNV, that relationship. So the number of moles is C times V. There's C, there's V, and I can work it out. I'll do that in a minute. The other thing that I need to put in here, I know the average titer for the hydrochloric acid, it's what I had in my burette, and I calculated the average a little bit earlier. So it's 19.83 centimetres cubed. So I'm going to turn it into decimetres cubed, and I do that by dividing it by 1,000. So the answer here is 0.01983. So that's my decimetres cubed. I've got no other information here. I'm going to have to calculate that from this side. It's a neutralisation reaction, so I know that it's a 1-to-1 molar ratio. So for 1 mole of sodium hydrogen carbonate will exactly neutralise 1 mole of hydrogen chloride, hydrochloric acid. If I have half a mole of this, it will exactly neutralise half a mole of that. So we've been doing this neutralisation in our titrations. So I need to work out the number of moles of hydrochloric acid, and I can do that from here. So concentration is 0.0952 times the volume in decimetres cubed, which is this, 0.025. It's worth saying, always write your equations. The examiner can follow your working, and it's pretty obvious what you've been working out. So when we do this calculation, the number of moles that I used in this was 0.00238 moles. As I said earlier, this is the balanced equation, so we have equimolar amounts of each one. So if I've got 0.00238 moles of sodium hydrogen carbonate, it will exactly neutralise the same number of moles of hydrogen chloride. So I can take that directly over here because it's a 1-to-1 relationship. So this is 0.00238. Now that's great because I've now got 2 pieces of information. I can calculate the third. So this is what I wanted to know. What is the concentration of the hydrochloric acid? So C equals N over V. Always write your equations, then you know what you're doing. Your examiner knows what you're doing. They can follow any mistakes that you make. So the number of moles is 0.00238 divided by the volume, 0.01983. And the final answer for that, put that into the calculator, and it will come out at 0.120 moles per decimeter cubed, and I'm just going to put that in again, moles per decimeter cubed. So that is the concentration of the hydrochloric acid that was supplied to me today.